This is Unit 1, Lesson 2 of Foundations in Pre-Cal 10 on applications of prime factors. So let's just review. We want to express the numbers 48 and 72 as products of prime factors. So that means we have to do the prime factorization. So let's do 48. 48, if I divide that by 2, I get 24. If I divide that by 2, I get 12. That divided by 2 gets me 6. That divided by 2 gets me 3, and 3 is prime unfinished. And so I get 48 equals 2 times 2 times 2 times 2 times 3, which I can also write as 48 equals 2 to the power 4 times 3. And sorry, this little squiggly thing of mine, that is an equal sign. I will try and write that more neatly, but I've been trying for years and not having much luck, so I'll just apologize now. We're going to do the same thing with 72. So 72, if I divide that by 2, I get 36. That divided by 2 is 18. 18 divided by 2 is 9. And 9 is 3 times 3. So I get 72 equals 2 times 2 times 2 times 3 times 3, or 72 equals 2 cubed times 3 squared. New now. Greatest common factor, or GCF, is the set of whole numbers that is the largest whole number which divides exactly into each of the members of the set that you're talking about. So the greatest common factor of 8, 16, and 20 is 4. Oops, 4. Because 4 is the biggest number that divides exactly into all three of those numbers. Okay, so the greatest common factor of 15, 25, and 35 is 5. And that one is one that you hopefully can see just because you know your multiples of 5. 18 and 20, the greatest common factor of that is 2. Now, the greatest common factor of 36 and 54, that's a little bit harder. We can do that one. For now, we can do it just by listing all of the multiples of 36 and all the factors of 36 and all the factors of 54, and find what's the biggest factor of all of them. So 36, we have 1, 2, 3, 4, 6. 6 times 6, 4 times 9, 3 times 12, 2 times 18, and then 36. And 54, we've got 1, 2, 3, 4 is not going to go, 5 is not going to go, 6 times 9, 3 times, I should know this, 8, nope, I'm sorry, I don't know this and I don't have it written down for some reason. So 54 divided by 3 is 18. Oh yeah, makes more sense. Okay, sorry. 18 and then 2 times 27 and 54. So to find the greatest common factor of those two, I go through the list and the biggest number that I see in both lists is going to be 18. So that's the greatest common factor of those two numbers. Yeah, and 18 times 2 is 36, and 18 times 3 is 54, so that does work. Okay, there's a better way to do that instead of writing out all of those factors. And I mean, writing all the factors out for those two was not too bad because they were relatively small numbers, but that gets really, really tedious if the numbers are big. So there's a better strategy, and that is using the prime factorization. So let's do an example with 48 and 72 and find the greatest common factor of those. And this is kind of gobbledygook the way it's written here. The way I do this is I'm going to write 48 equals 2 times 2 times 2 times 2 times 3, and 72 equals 2 times 2 times 2. So there's my 2 times 2 times 2. And I need to put a 3 times 3, but I'm actually going to line the columns up. So I'm going to skip this space here because I don't have a fourth factor of 2. But I'm going to put my 3 here and my 3 here. And then my greatest common factor is going to be all of the ones that I have common to both of them. So there's that 2 and that 2 and that 2 show up, and that 3 shows up. So the greatest common factor is going to be 2 times 2 times 2 times 3, which is 8 times 3, which is 24. So 24 is the greatest common factor of 48 and 72. All right, let's do a couple more examples doing this. All right, so use prime factorization to find the greatest common factor of 90 and 225. So I'm going to do this up here. So 90, if I divide that by 2, I get 45. If I divide that by, I can divide that by 3. I'm going to follow my rule of writing them in, doing them smallest factor possible so that these end up in order. It just saves work later on. So 45 divided by 3 is 15, and that is 3 times 5. So 90 equals 2 times 3 times 3 times 5. And then 225, that divided by 2, but I can divide that by 3. And that gets me 75, which, since 7 plus 5 equals 12 and 1 plus 2 equals 3, I know this can be divisible by 3, which is 25, and that is 5 times 5. So I'm going to write my 225 equals, I don't have a 2, but I've got a 3 times a 3 times a 5 times a 5. So my greatest common factor is going to be the ones that show up twice. So it's 3 times 3 times 5, which equals 45. And that's the greatest common factor of 90 and 225. And it's not a bad idea to just take a second and divide those both by 45 and make sure that it works, because mistakes happen and we want to catch those sooner rather than later. Okay, let's do these two, 154 and 198. So I'm just going to do the factoring across the page this time, just to show you how it just looks a little bit different if I have a different sort of space available to me. So I'm going to go 154. If I divide that by 2, I get 77. And yes, I'm using a calculatus. And then 77 I know is 7 times 11. So I get 154 equals 2 times 7 times 11. And then 198, if I divide that by 2, that's 99, which is 3 times 33, which is 3 times 11. So I get 198 equals 2 times, I don't have a 7, but I have an 11, and then I have 2 3s. And okay, they're not in the correct order, but that's not the end of the world as long as I've lined up everything that I can. So I've got a 2 is common and the 11 is common, so my greatest common factor is going to be 2 times 11, which is 22. So 22 is my greatest common factor of those two numbers. Okay, and we'll do another example when there are 3 numbers that we are doing the greatest common factor of. So let's factor the 3 numbers. I have 245, doesn't divide by 2, doesn't divide by 3, but it does divide by 5. So I get 5 times 49, and I know that 49 is 7 times 7. And then 315 doesn't divide by 2, but it does divide by, I didn't follow my rule. I divided it by 5 because I could, and then I put the calculator. So, there's the way that's ideal to do it, and then there's the way that I sometimes actually do it. Anyway, my calculator tells me that that's 63, and I know that 63 is 3 times 21, which is 3 times 7. And then 770, if I divide that by 2, I get 385, which if I divide that by 5, I get 77, which is 7 and 11. So this time I'm going to look at this and sort it in order. Actually, let's do this a little bit different. Let's just look at these this time and see if we can see which numbers show up every time. So there is a 5 in all of them. There's a 5 there and a 5 there and a 5 there. And then there's a 7 in all of them. So there's a 7 there and a 7 there and a 7 there. So my greatest common factor is going to be 5 times 7, which is 35. Okay, cool. All right, now we're going to do the least common multiple. And um, we get these mixed up a lot. So you have to think about what's a factor and what's a multiple. A factor is something that goes into it and is smaller than or as big as. A factor is never bigger than the thing that it's making, right? So the biggest factor of 35 is 35. So the greatest common factor of 35 and some other number can only be 35 is the biggest it can be. It's usually smaller. The lowest common multiple is the smallest number that is a multiple of both or all of the numbers you're talking about. So multiples of 6 are 6, 12, 18, so on. Multiples of 8 are 8, 16, 24. Make sure that you're including the number itself because that is 8 times 1 or 6 times 1. So it is a multiple, so make sure that you're doing that. The lowest common multiple, oh, sorry, this just says common multiples of 6 and 8 are anything that shows up in both lists. So 24 shows up in both lists. So 24 is a common multiple. 48 is a common multiple. There are a whole lot of common multiples. We're usually interested in the lowest common multiple. So in this case, it's 24. Just like when you're looking for, when you're adding fractions and you need a common denominator, you want your lowest common denominator is going to be the lowest common multiple of those two denominators. The lowest common multiple, you can do these ones by, well, the old way you would do it is if you could write out the multiples of these, I guess is what you would do. So the multiples of 5 are 5, 10, 15, 20, 25, 30. And the multiples of 7 are 7, 14, 21, 28, 35, 42. Now I haven't found a common multiple yet. Maybe I'll go back up here and continue listing these. And the next one is 35, which, oh, yay, that one does actually show up in both lists. So my lowest common multiple of those two is 35. For 10, 15, and 20, there's a little bit of a shortcut that you can take here because 20 is a multiple of 10, so anything that's a multiple of 20 is also going to be a multiple of 10. So I can actually just ignore the 10 and I can write out multiples of just these two numbers. So I got 15, 30, 45, 60. Multiples of 20 are 20, 40, 60. And notice that these are also multiples of 10. So I don't need to worry about the 10. And then my lowest common multiple here is 60. The 10, 12, and 14, I just don't feel like writing out, so we're going to skip that one. All right, now we can use the prime factorization to find the lowest common multiple as well of numbers. So we're going to take all of the prime factors. Again, this is kind of wordy. You take you take the prime factors of one of the numbers and multiply it by additional factors in other ones. I'm going to show you the way to set this up that makes sense. Instead of writing the numbers like that, I'm going to go, well, 10 equals 2 times 5, and 12 equals 2 times 2 times 3. So I'm going to put the 2 under there, and then I'm going to put the 2 and the 3 out here because we're looking for columns again like we did before. And then 14, I've got a 2, not a 5, not a 2, not a 3, but a 7. So these are, so my greatest common factor is going to be 2, but my lowest common multiple is 2 times 5 times 2 times 3 times 7 because it's basically every column that I have to take. Okay, yeah. So if I multiply that all together, I get 420. And I'm glad that I didn't write out all of the multiples up to 240. The key thing here is that this 2, because it shows up in all of them, only counts once. Okay. Okie dokie. Next, let's use prime factorization to find the lowest common multiple of these ones. So I know that 15 equals 3 times 5, and 35 equals 5 times 7. Now I sort of cheated on that because those are all the prime factors. That's just how you multiply. It's the only way, other than 1 and the same numbers. That's the only ways you can multiply this. So the lowest common multiple is 3 times 5 times 7, which is 105. All right, and just a reminder that the greatest common factor here is literally greatest common factor, which is 5. Okay, that's the common factor for those two numbers. All right, let's go to gray for this one. Okay, 100, oh, I did blue. 126. I have to factor that one. So 126, if I divide that by 2, I get 63. If I divide that by 3, I get 21. And that's 3 times 7. 441, I can divide that by 3. That's 147. Divide that by 3, I get 49. So that's 7 times 7. So I've got 126 equals 2 times 3 times 3 times 7, and 441 equals 3 times 3 times 7 times 7. So the greatest common factor is, these are my columns. So I get 2 times 3 times 3 times 7 times 7, which equals 882. All right. And my, oops, I got that backwards. I'm so sorry. That is, I haven't found my eraser on this properly yet. They made changes to my software over the summer. They upgraded it. I hate it when they do that. Delete. This is my lowest common multiple. I have to get that right. This is my multiple, lowest common multiple. My greatest common factor, oh, come on. My greatest common factor is going to be 3 times 3 times 7. So my greatest common factor is 3 times 3 times 7, which is 63. Okay, there we go. Didn't ask for that, but it's worth taking a look at that. And finally, we want the lowest common multiple of all three of these. I'm going to use different numbers for this third example because I don't love this example. So we're going to use, instead of these numbers, we're going to do 44, 66, and 165. So the factor 44 divided by 2 is 22, which is 2 times 11. 66, divide that by 2 is 33, which is 3 times 11. And 165 doesn't divide by 2, it does divide by 3. I didn't do that one already. That comes up to 55. Okay, which is 5 times 11. So now we're going to write all of these out in our rows. So we've got 44 equals 2 times 2 times 11, 60. Oh no, why is my calculator, my computer's frozen. 66, whoops, equals 2 times 3 times 11. So I'll go 2 and 11 and 3 because the 3 needs to be in its own column. And then 165 is, I've got the 11 here and the 3 and the 5. So I can stack anything that I can stack, I'm going to stack. So I've got a 3 in each of these, so I can stack those. I've got the 11 is in all of them. There's a 2 in just these two, and there's an extra 2 in 44. So my lowest common multiple is 2 times 2 times 11 times 3 times 5, which is 660. And my greatest common factor, it used to be so much easier to change pen colors. Snappy today. And then my greatest common factor is 11. All right, that is it for this video. Go and do questions 1 to 7. Bye.